Hello, everyone, and welcome to SLOconf Monthly. Today, we have Alex Palcuie from Google with us. He will be talking about going from 30 to 30 million SLOs. I'm very excited to have Alex. I was telling Alex earlier that we've had a few Googlers talk here. Fun fact, we actually had our first ever SLOconf Monthly at the Google office in Seattle. So it's always nice to have someone from Google here talk and educate. And I am Erza. I work for a company called Noble9. And today we will have Alex, like I mentioned before, talk. And after that, we have a breakout session where we will just separate y'all into different rooms and just have some socializing time. And at the end, we have a Q&A session. And I'm hoping that you guys can share some questions and discussion with Alex about his talk. And that being said, I will let Alex go ahead and present. Alex, whenever you're ready, feel free.
Yep, thank you. So my name is Alex Palcuie. I'm a site reliability engineer at Google Cloud. I work on the team that takes care of the Google Compute Engine control plane. This is where you can create and run virtual machines on Google's infrastructure. And I'll be talking about our journey that was going from a handful of SLOs to like millions of them, and how this in the end managed to improve the customer experience. It had a bit of pain on the SRE side, but it was worth it. Let's talk about what the control plane does. So when a user sends an HTTP request to compute.googleapis.com to create a virtual machine, we first authenticate and authorize the user. Then we verify that they have enough quota. Then we check the status of their billing account. And at the end, we return an ID for what we call a long-running operation. Now, the user can pull this operation and see its status. Asynchronously, the backend code goes and grabs some cores and RAMs for the VM from Borg, some disk space from our storage systems, talks to the networking folks to set up the virtual networking, and maybe gets a public IP address. Now, these backends have their own backends, and I've collectively labeled them as TI, which internally stands for the Technical Infrastructure Organization. These are the base services on which almost everything at Google is built on. Finally, we package everything and give the VM to the user by updating the operation that I previously discussed. And once we've returned the correct operation, our job as a control plane is done. We are not responsible for keeping the VMs alive and running. We're not responsible for making sure the disks offer the right I/O performance, and we're not responsible if the networking does drop packets. These are the jobs of other teams running the GCP cloud, and we typically call them as part of the data plane. But GCE doesn't mean only virtual machines. We have many more resources in our API. So for example, VMs can be put into an instance group manager to treat them more like cattle. Disks are needed to store data for computation, and we can take snapshots of them and maybe create images that other VMs can boot from. We could attach an autoscaler to our instance group manager and scale it up or down, depending on how many customers we have. And on the networking side, we have networks and subnetworks for partitioning. Every VM has an internal address, but you can rent a public one. And for added security, you can establish firewall rules for those public resources. All these resources and several others have all the create, read, update, and delete API methods you would expect for managing them. And not only that, but we need to provide these features across many locations. Our users expect that a control plane stack in a region in the US will fail independently from another region there, or from another region in Europe. And we provide this across the whole world in like more than 40 regions at this point. Now, before I'll delve more into GCE, let's make sure we're on the right page with the three acronyms. And I'm now at SLOconf, but I'm not sure if they're established in our industry at all. So it's always best to remind us. So an SLI is a carefully defined measure of some aspect of the service. Most services have request latency as an SLI, or another one is like error rate. An SLO is a service level objective, a target for that service level indicative. For example, we might decide that we'll create VMs quickly, and we do that by adopting that the 90th percentile should be less than 2 minutes. And finally, SLAs or service level agreements are an explicit or implicit contract with your users that have consequences if you meet your SLOs. Typically, the consequences are financial, either like a rebate or credits, but they can take other forms if the SLOs are internal. Also, typically, the last one involves lawyers, whereas the first ones don't. So I'll focus on the first two ones. The GCE control plane SLOs are like the textbook case for how to implement the concept. We define our availability SLI as the number of good requests divided by the number of total requests. A good request is a request which is not an internal error. So for example, I'll claim that the availability SLO for creating instances in the zone US Central 1A is 99.95%. This means that out of 10,000 requests, 5 are allowed to be bad and the rest should be good. Now you'll see me throwing numbers of 9s around here. These are not our internal targets. They're just representative of the ideas that I'll be trying to explain. Let's talk also about latency. An example of a typical latency SLO is that the 90th percentile of compute instances get, which is an API method, should be equal or less than 10 seconds. Now let's imagine that our system has received 9 requests with latency times going from 1 to 9, and all our percentiles now will match the latency. However, by default, your typical monitoring system stores latency entries in histogram buckets. And so let's say we have this exponential increase in bucket size where the first one is size 1, the second one is size 2, the next one is size 4, and the fourth one is size 8. When you ask your monitoring system what is the P90, it will give you a value between 7 and 15 in this case. It will probably do some linear interpolation and try to be smart, and it might give us a 9 here. But here's what's worse. If I change the duration of the last request, the buckets don't change at all. Now I'm violating my SLO, but the naive percentile would yield the wrong answer. So the solution is to turn latency SLOs into something similar to availability SLOs by counting how many slow or fast requests we have. Now, the target latency is similar to how we calculated the availability. We define it as the number of fast requests divided by the number of total requests. And a fast request is one that's within the 10-second target latency. Then we go and set the target to the actual percentile we're tracking, which in this case is the 90th. If we do the calculations for the latency, when we had 1 request out of SLO, I get that we had 8 good requests divided by 9 total requests, which gives me 88% availability. Availability put there in quotes because we're talking about latency here. On the right hand, we have 9 out of 9, which gives us 100% availability, again in quotes. The simpler way of tracking, this is a simpler way of tracking latency, and it allows us to have less storage, and it simplifies the calculations. Though the downside is that we lose a lot of data about our distribution. But we don't really care about that when we compute latency SLOs. We can even aggregate multiple API methods under the same latency SLO. So for example, in the top right-hand corner, I've added a slower instances list where the P90 is 30 seconds and even a slower instances insert with the P90 being 60 seconds. On the left table, I've listed 10 requests where 9 of them are fast, taking the rules from the table, and 1 is slow. We're now measuring if the entire system is fast enough at the 90th percentile across many methods. And we're trying to find regressions as a whole and not only for a specific method. And with this all, we have all the necessary information to understand the initial definition of the GCE control planes SLOs. So back in the early 2010s, when we launched, we decided that we should have for each zone and region an availability, typical latency, and tail latency SLO. For example, we would get paged when US Central 1A had poor availability, or when Asia East 1C had degraded typical latency. The typical entail just had different percentiles. And there were no per API alerts, though we would typically catch when one API was broken by the virtue of setting our availability targets very high. And this allowed us to have a manageable number of approximately 30 SLOs. Strategy worked for a while and we were happy, but we have a Pareto principle distribution of requests where like 80% are reads and just 20% are mutations. So when our QPS increased, tracking the health of the system on a per scope basis actually meant we were tracking only the read requests, which are also not as high value as the mutations. So when a high value low QPS method broke, we were alerted only when the burn was severe enough and it was prolonging outages. So we decided to add API method alerts in 2016. Now, we would get paged when compute instances list had too many errors, or when compute disks list had a tail latency regression. Rather than have the number of scopes times the number of API methods, we opted for the number of scopes plus the number of API methods. This took our number of SLOs somewhere in the hundreds, but it was still fine as we set data thresholds for high QPS APIs and lower alerting thresholds for low QPS API methods. And again, this strategy worked for a while, but unfortunately, we grew again. So fast forward to early 2021, we can see the increase in the scale. The problem now was that we were alerting only when a high QPS method broke in a zone or when a high QPS zone broke a method. Small and medium zones in regions would not move the needle enough for our biggest API methods, and sometimes would fall through the cracks. Even worse, we'd have outages where a newly launched region, which was small at the time, had specific broken lower QPS APIs for a long period of time. And these sorts of things did not go unnoticed, even in the outside world. So Rachel Kroll, who writes on Rachel by the Bay, has a blog post where she describes a bad experience with one of the big platforms that, and I'm quoting, they are huge. They are like a giant which lumbers around while you're a gnat. You are nothing to them. This becomes obvious when talking about some problem we experience at the hands of their system. The whole time their dashboard stayed green because from their point of view, they had tremendous availability. Talking 5 nines here and it's totally legit. Now, I'm not sure which platform she's talking about, but continuing in the same vein, meanwhile, you're having a bad day, nothing was working, your business was in shambles, your customers were at your throat yelling for action, and all I could do was point at the vendor. What happened? Well, this is the point where you find out that their 5 nines availability is for their entire system. They see that and they're good. It's not a problem. Everything is fine. You're the bug on the windscreen of the locomotive and the train has no idea you're even there. And this got on the Orange website, upvoted, and everybody concurred. Million times this, it's shocking how elevated rate of errors for a specific endpoint is actually amplified to be a soft outage. I empathize with this feeling, and this is the problem my project has tried solving. And while it's not perfect, we've seen improvements. We started first with getting a matrix of SLOs. You can see here a dashboard where as rows we have methods and as columns we have the scopes. The squares, there are SLO budgets over the last 30 days. Green means okay, red and black means we've exceeded that budget. Gray means that we have a bug for that particular SLO and we're working on fixing it. We initially had 100,000 squares that we had to take good care of. And I call this the beginning of our curse of dimensionality. But there's a problem. We're still very far away from the user. We can say when a part of the GC control plane is broken, but it's still abstract. We don't know which of the black squares we should be focusing on. However, let's simplify the previous matrix. And on the y-axis, we have the scopes. And on the x-axis, we have the API methods. That's the 2D view. But we can improve it and add the third dimensionality that represents our customers. We have, let's say, 1 million customers that we care about. The number doesn't matter. It's the fact that it's orders of magnitude bigger than the previous 2 dimensions. This means that in theory, we could have billions of SLO budgets, but and they would be like rooms in the building. The real number, though, is closer to millions because not all projects use all the API methods in all the scopes. So this big number, close to the 30 million, when I was building the system, wasn't the problem. It was the false positives when the budget was blown. So when we say 99.95% reliability, what we actually mean is 10,000 requests allows us to have 5 errors. We can scale that further and say 20K allows us to have 10 and 40K allows us to have 20 errors. But if you go the other way around, we automatically say that 1,000 requests or less allows us to have 1 error. So if it happens that the customer sent us 100 requests and had 1 error, we mark it as out of SLO. That doesn't necessarily mean that they had a terrible user experience. They were just a bit unlucky and we're running the system at the high scale. And this skewed our data and made us appear worse than we actually are. To fix this, we could have said, oh, you need to send 10,000 requests for being eligible for an SLO. But that's like a binary way of how you track customers to be satisfied. And it will, like, again, have worked only for our biggest customers. We came up with the rule of 5 errors, where for each SLO budget, if you've sent less than 10,000 requests, we need to have at least 5 errors for us to be alarmed. This gives us the beautiful logarithmic graph on the left, where you start with 50% reliability if you've sent 10 requests, go pretty fast to 90% reliability if you sent 50 requests, hit 2 nines at 500 and 3 nines at 5,000. As you go infinitely to the right, the line stays at 99.95. And this rule can now be applied to our millions of SLO budgets where we have few requests and it will give us a few false positives. And we can even start counting the number of affected customers. Now, this is a time series of the number of out of SLO projects. We consider a project or a customer as being out of SLO if any combination of API method and scope is out of SLO. So if you go back to the 3D building that represents our SLO budgets, every floor is a customer. So if a floor has one room that's red, we count it as being out of SLO. The red lines are when we have outages. Then the green lines are 30 days afterwards when we go out of the SAD outage. And you can clearly see the spikes when we had incidents and then the line going down 30 days afterwards. We've had even 3 consecutive outages and then like healing pairs. Or in the middle, it gets messy because outages don't expect another 30 days to pass until they happen. So they could happen even in a smaller chunk. And there's also like a small burn always there, but we've managed to quantify it, point out to the devs what to fix and in which priority and how much impact that has on our customers. The way we've implemented generating the data is by running a data analytics pipeline over the logs. The pipeline starts daily, sometime after midnight, and that's Mountain View midnight for the folks who are familiar with time zones inside Google. And it runs for about 12 to 14 hours. Every day we materialize the definition data. We keep this under version control as a protocol buffer, and each dev and SRE is empowered to change the definitions. Then afterwards, we run it through a series of nodes where, for example, we exclude user errors, or we exclude API methods that don't exist, but somehow were asked in our requests. On the real-time alerting side, we have much less granular data, and that's because the cardinality of our alerts would be too much if we were to include them. Here's a sample of a report in our organization. So you can see in the first table, a list of the worst SLOs for which we burned the entire SLO budget, ordered by the number of out of SLO projects. And you can see that for compute region instances recommended in Union Central 1, we're doing the worst. We've had more than 2 times the allowed budget, and more than 500 projects have been affected. But you can observe the next entry, which is compute instances insert, which has consumed 4 times the budget. However, much less projects are affected by this. So by the previous naive rule, we would have focused on this, but now we know it's not as important as the first one. Then the next table shows all the SLOs for which we haven't yet burned the overall budget. You can see that by the fact that the ratio of SLO used column is below 1. However, we're still violating the reliability target for lots of customers. Here, the first entry shows instance group managers get, in aggregate, has used 25% of the budget. But for 289 customers, we've used the entire budget or even more. And now we would have, we're able to pick these things and also prioritize them as the previous ones. The last table, we showed the most offending, we call them bugs, but you can think about them as Jira tickets, where we try to link issues to things that actually affect our customers. Here we can see that get yes attributes is the worst one. And by following that link, you would see a discussion between the devs and the SRE about the current problems and the next action items. Thank you very much. This was my presentation for today.
Awesome. Thank you so much. That was incredible.
Well, I actually shared something kind of very fun in our group. And I don't know if maybe everybody else wants to see it, but we made a new game, which I'm sneak peeking here. Aged at 3 a.m., respond or ignore. It's a little card game. Everybody in the right breakout had fun, right? Yeah. Yeah. So I thought maybe we'd play a couple cards here for everybody else who didn't join. So if I get a repeat, Alex and Trent and Carrie don't cheat here. But you guys want to play a game? Chris,
that sounds
George,
ominous when you say it like that.
There's a couple people here. Okay, guys, I'm going to draw a card. It's very simple. I'll read the instructions. Draw a card, decide to ignore or respond, flip the card to learn the right choice. You may attempt to leave the game at any time by switching to a management track. Simple game. Okay. I'm going to pull a card. I'm going to go to the middle of the deck because I started at the top before. All right, here's the first. Oh, here's the first card. Can you read this? Carrie, read it out for people.
Sorry, 99% CPU utilization on Linux server over the last 10 minutes.
Respond or ignore?
Ignore, it's the backup.
Chris says ignore. Anybody else?
Ignore, it's just a machine.
It's an ignore. I can't read it now as I'm looking at the other side, but it's ignore. It says, if you have meaningful SLOs, you'll find out when this actually causes problems for users. You can investigate in the morning. All right, next card. Here. Take a look at this one. Respond or ignore?
Carrie, did we have this card?
We did.
My group already had this card. So.
Going down.
What's that?
It's hard to read.
I can't quite read it. Is it 500 errors going down?
The error message at the top says HTTP 500 is leading to budget burn of 10x normal. The reliability is going down. The red line represents this is the reliability burn down. It's below the SLO here. Respond or
Respond.
respond. This is a respond. It says your service is either completely down or performing terribly and likely requires immediate human intervention. All right, and then let's do another random one. Here we go. I don't think we saw this one before. One host down, two hosts up. What do you guys think? Respond or ignore?
Depends on what it is.
Ignore.
That's an ignore.
Yeah. It depends, but also ignore.
Ignore. With a very long explanation, it says, SLOs provide a buffer for a certain amount of expected failure. You can use them to let you know if one host out of 10 is actually causing your users problems, or if you can absorb this failure and check on things later. This is an ignore. Okay. Maybe do one more. Here, we'll do one more. This one might be hard to read. Actually, let me grab a different one. This is hard to read. There's another really fun one in here. Hang on a second. I'm going through the whole deck now. Here's one. Here, we'll read this one instead. Acme Cloud. I think that to replace the name of a real cloud. Incident. We're investigating. What do you guys think?
Is this for me because I work on a cloud?
Alex has to respond because it's a cloud. Yeah. Anyone else? Respond or ignore?
It depends. It depends how much it's affecting us. Ooh, nice.
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 If you haven't gotten other alerts, then everything failed over properly and you can go back to sleep. But will you really be able to? Anyway, if you're coming to reInvent, you can play this game with us and get a copy for yourself. And it's, I think Carrie has a drinking game version of it. So, you know.
Anytime you have to respond, you get to take a shot.
Does anyone have questions for Alex?
I have a question for you. As you're looking at other services across Google Cloud, do you see that this set of techniques that you're developing is catching on with other teams? And this is my first question. And my second question is, imagine somebody who's not aspiring to Google Cloud scale. How would you kind of apply some of these techniques to the earlier stages, or like, what are the things that would be like, don't shoot yourself in the foot early so that it scales nicely for you later? Like, what would be your advice for somebody who's just starting out on an SLO journey that maybe isn't going to scale to that level?
Yeah. So on your first question, the one with other teams, unfortunately, my team is special in the sense that we have the biggest API surface we think in the whole Google. We've talked with people in ads who have this API surface. We don't think their surface is as big as ours, unfortunately. So it was a homegrown problem that there was no, we had to come up with ways on how to scale it out. I see some of this appearing with other teams, like I talk, for example, the control plane team that actually runs the VMs. Their entire API surface, they joke, is the x86 API, which is like, can you put an SLO on instructions and things like that? No, you cannot do that. So they have to approximate, like when a VM is healthy and when a VM is not. So it doesn't work. But at the same time, I do think that these kinds of have an SLO for a customer is starting to catch on even inside Google. And are you able to track how many customers are happy or how many customers are unhappy? It started to take action, because as Rachel said, if we look in aggregate, everything is many nines because we're running things at a big scale. But if we look in certain particular customers, it's not true. And I think there's a culture movement inside Google that has to happen, because from a consumer point of view, almost all the consumers are the same. If you use Gmail or search, you're using it the same. But from your enterprise perspective, cloud way, almost all the customers are different. People pick and choose which parts of the cloud they run. Somebody is like high KPS, somebody is like high volume. So you really need to treat every customer very as important as each of them. So yeah. I think that's where I'm going with the first one. The second question about how you not should shoot yourself in the foot, don't start with complicated things. Like my entire talk has been, we started with the simplest 30 things that we could imagine and went for the next 100 ones. And then we went for the next 1,000 ones, and then we went for the millions. So I would love my product to go back to the simple 30 ones, because it was so easy to debug and it didn't have any problems. That now onboarding people and explaining them why we're doing things such complicated takes time. So yeah, don't start with it complicated SLOs, especially because now you have to explain it to them.
Do you on the point about 30, obviously no human can rationalize or kind of reason over 30 million SLOs. So you have some higher order of abstraction. Is there some way that you think about like a group of 1 million SLOs being consolidated into something that is really just one SLO? I mean,
yeah, exactly. So my SLO is how many customers are affected. It's like the squeaky line that I told you, and the floors in the big building. I care to have 0, that number. I want 0 customers to be out of SLO. If the SLO needs attention, like if I've set my metrics too low, this is where you tweak them. And this is where you affect them. But at the end of the day, I should have 0 out of SLO customers. We've never seen that happen, just because problems everywhere in the system and things like that. But at the same time, that's where the aggregation should happen. It shouldn't happen at the API level, and I don't think it should happen at the scope level. Like there's no way for me to say to people, hey, US Central 1 is fine. No, that's not a thing. Are my customers fine? And it is each and one of them being happy.
Awesome. Yeah, that makes perfect sense. Thank you so much.
Feel free to use this QR code to join our Slack channel where we have discussions. Somebody mentioned that they're trying to network and looking for new job opportunities. Feel free to join the Slack channel, actually, because we have a Slack channel specifically for people that are looking to switch jobs or looking to network. And then If you have not heard about Slow DLC, I suggest it's also another community edition. I suggest you guys to check that out. Slow DLC was created by practitioners in the community with the intent of creating practical and useful materials, templates, and examples to aid organization in their SLO journey. So check that out if you haven't. Just use this QR code and it will take you straight to the website. If you're going to reinvent, like Kid mentioned before, and you want to play this game with Kid and Carrie, make sure to check out the Noble 9 booth. We will be there. And you can use, if you want to just set up a meeting to talk about SLOs, you can also use this QR code or just come check out our booth.